I love algebra is what you should say at a party if you want people to look at you strangely and then walk away from you. Because people don't like maths, but people have a special hatred for algebra. You know, it's not just the subject of funny things, it makes people legitimately anxious, right? Now, this is an issue because algebra is really important, right? However, algebra embodies everything that people dislike about mathematics. It is the boring and repetitive manipulation of usually vague and meaningless symbols according to arbitrary, sometimes contradictory rules to solve problems, contrived problems that no one cares about. Okay? Now, can I just say a quick word about the contradictory rules? I don't know how many of you have taught introductory, like Year 7 and 8 algebra recently, but think about when you labor to explain to them, hey, see this thing? Two solutions. Not one, two solutions. And then you drill into them and you're like, yes, I get it, they get it. And then you give them this and they say, yeah, plus or minus 5. Because you told me, you banged me in the head until I got that there were two solutions. And you're like, no, but wait. So they get, this contradiction in their head between, well, I don't know, the rules are just random. Don't try and understand them, they're just what they are. The teacher said so, that's all I need to know, okay? No wonder students disengage. Now, I said this is a problem. Part of the reason why it's a problem is because algebra is a keystone concept. It's right at the heart of developing so many of the working mathematical skills that students need. And yes, I have the new diagram, right? Just think, okay, reasoning, right? Yes, deductive geometry, which bye-bye, year 11, 12, deductive geometry, but reasoning from one line to the other in algebra is like the main place where they first get, okay, one line, then the next one, and they hang together, okay? How about problem solving? Translating a verbal problem into symbols that you can then manipulate and solve a problem with, right? I could go on and on. Algebra is right at the heart. You don't need me to convince you of that, right? Now, this is a problem even for the students who aren't just the ones who struggle, but those who are, quote unquote, good at algebra, by which I think we take to mean they're fast, they're accurate, but do they really understand what's going on? My favorite example of when this doesn't happen is completing the square, okay? So let me show you, for instance. You limber up your brain. Let's do something like this, okay? So here is a quadratic equation, and we can complete this, we can solve it in a variety of ways, but let's complete the square, okay? Now have a look at the left-hand side. What's the thing you've got to add? Think about it, go back. Come on, tell me. It's 9, right? You say there's a 6x there, so you halve the 6, and then you square it. So half gives you 3. Then you add 9. Since you added it to the right, left-hand side, you should add it to the right. And you're like, oh, lo and behold, the left-hand thing is now x plus 3 all squared. That's 64. And then off you go, and you can solve it. You can solve it. But how many of you actually get what happened from here to here? Right? How many of your students actually can tell you, explain why that step works, even though they're good at it, they don't get it. Right? So what I'm suggesting today, what I've got for you, my goodness the time, is a method that's based on algebra tiles. Okay, hands up, who's seen algebra tiles before? Okay, good, a number of you. I don't have algebra tiles because I'm cheap. So I'm going to show you, basically, now I want to stay here, I want to show you a key insight that algebra tiles have given us, which we can use, which is simply algebraic terms can be represented by areas. That's it. Terms, areas. Let me show you how this is helpful. If you think of an area, a term like say 6x, okay, I can represent that as 1, 2, 3, 4, 5, 6, something like this. Here you go. This side length is 6. That side length is x. It could be long, it could be short. It doesn't matter because it's x. So that makes that 6x. That's 6x. Okay? Now this simple idea unlocks so many things, like for example, why no one reads that as x to the power of 2. We say x squared because that's what it means. It's a square of side length x. Okay? Now let me show you some simple ways that you can illustrate this and how it's helpful. Okay? 2a plus 3a. You will encounter many students who will tell you, oh yeah, that's 5 a squared. You combine the 2 and the 3, you combine the a's, no problems, right? And then you say, no, you just combine the 2 and the 3. You leave the a there, and they're like, okay, sort of get it, fine. And then you give them this, and they say, ooh, I remember what Sir said. You combine the numbers, but you don't combine the letters. You know, that's 6a, why not? Now, if you think of these as areas, it's really simple, right? 2a plus 3a, what might that look like? Here's a 2, let's call that a. So 2a. What's 3a look like? There's 3a. There you go, 2a plus 3a. Well, when you put them together by adding them, you get 5a, not 5a squared. There's no a squared in there, right? Or how about the next one? 2a times 3a. Okay, well let's make this 1a and 2a and 3a. 1, 2, 3. Okay, there you go. So this is 3a all the way across. What's 2a look like? 1, 2, 3. There you go. That's 2a. Okay, so that's 2a times 3a. But what do you see? It looks to me, sorry that's so messy, that's a and a and a. These are all a squared. How many are there? There are 6, of course, right? Now, where this really shines, I think, is where you go back to this, right? Completing the square. You remember this business? All I've got time for you to show you is just how this works. What's this mean? Okay, x squared plus 6x. Let's draw a picture. Here's x squared. Let's call that x and x. Here's 6x. 6x. You remember we halved it, right? We halved it. Why did we do that? Well, let's see what it looks like if you halve it. If you halve it, you get 3x and you get 3x, right? Do you agree? That's what the halving does. Now, why is that useful? Why is that useful? Why does that construction mean anything? It's because if you take this guy, you can shove him on the end. You can do that because it's x across, right? And then you can take this guy and you can say, oh, all right, well, let's combine him like this. You can do that too, because that's x still. What should I do with this? What should I add that's meaningful? Oh, there's something over here that begs to be completed, right? What is it? It's 3 times 3, that's 9. Why is it called completing the square? Because there's a square and you're completing it. And that's why when you factorize, what is this? It's x plus 3 all squared, which is 64, and off you go. You know what? I love algebra.